LeetCode problem 1161, maximum level sum of a binary tree. Given the root of a binary tree, the level of its roots is 1, the level of its children is 2, and so on. Return the smallest level x such that the sum of all the values of the nodes at level x is maximal. Okay. So we have example 1, root is number 1, 2 children, 7 and 0, 0 has no children, 7 has children, and that's 7 minus 8. And our output is 2. So level 1 is 1, the sum of level 2 is 7, and the sum of level 3 is -1. So level 2 is our answer. Oh, okay. And then we have example 2. Our root is 989, no, 1025. Okay, I think this one I need to visualize it because I can't really tell. So it's gonna have one child, that'll be no, and 10250. And I think I'm doing this right. I actually haven't done it in a while. So this will be 9, 8, 9, 8, 9, 8, 6, 3, 9, and then negative 8, 9, 3, 8, 8. And then we come down here. It will be no, 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 and 0, 2, 1, 2, 7. Okay, so level 1, level 2, level 3, level 4. Right? 1, 2, 3, 4. So, and then its output is 2. So this one. So we can check. We can just do 9, 8, 6, 3 minus 8, 9, 3, 8, 8. So that's 9,305, 9,305. And then we can do this one, which will be, we don't even need to do it. That will be negative. And then this one would be 10,250. Okay, so this is the biggest number and it's at level 2. Okay. We got the gist of the question. So we do want to go through each level, add it up, and find the total. We want to find the totals of each level, and then the level, the smallest level that has the largest number. And I'm guessing that one has to do with, if it's a tie, we want the smallest level, because it wouldn't make sense in this example or the example 1. So we can do the same thing we did last time. We can have our guard in case it's empty. We'll have our queue, and then we need to keep track of our level and then the maximum so far for a level. So that's what, 3. That's 3. Okay. So we can do a guard let root.
You've got mail.
Oops. I'm gonna mute my phone. Guard let root equals root else. We're gonna return 0. Okay, we're not returning an array, so we can do that. And then we can do var q. This will be tree node. We'll start with our root inside. Then we need our highest level. No, highest we need. This will keep track of our biggest level, biggest sum. Okay, let's just call it biggest sum. No. We need to keep track of the level that has the highest level. It shouldn't be so hard to name variables. And then we just need to keep track of our current level. Should we start this off at 1? Yeah. This probably should be 1 too. Because we have a root. If we get this far, we have a root. Root is level 1. We need a variable also to keep track of our the biggest sum on the level. Okay. Biggest sum on the level. Let's do this. And then we will do our we can return our highest level. And then we can do while our queue is empty, while our queue is not empty. Queue. And we can do our remove last. Do we need that for this? Okay, we need to know when we're on a level, how large the level is, how many nodes we have on that level. So we can do our level count equal q count, and then that level, we need to keep track of that level sum, because that's what we'll do, like a max, and then pass in these two variables, biggest sum and current level sum. And we can do this 0, right? Okay, so we have our variables. Now we need to do our loop. We want to loop through our level. For I and and then here is when we will do our remove last. So let's current level node. Current level node equal q. Remove last, not remove first. It is remove first, not I don't know why I keep doing remove last. Let's remove first. So we're removing our first, and then we want to check. Okay, so we remove. Okay, so we're on our level. Remove our last. No, we just made a variable for it. So we want to add to our current level sum. We want to increase it of our node values. How am I going to write that current? We can do current level sum plus equal current level node value. Okay, so this is our bread and butter, and then we just need to add our children. So we can do if let left side equals q dot left, or no, not q, our current level node dot left. So we're just getting the children of the nodes for the level that we're on, right? And then we're appending them to the queue so that when we go through it again, we have something to work with, if there is something to work with. So we've done the left, now let's do right. So we can do Q, append the right side. So we're adding up our current, we're adding up the left, we're adding up the right. So what do we check here? So this is where we're gonna set our max sum, our biggest sums, and our highest level. I think so. So how do we do that? We can do an if statement. So if our current level sum, that's what we're doing in our loop. Add in if our current level sum is bigger than our biggest sum, then we need to start reassigning sums. So our biggest sum is gonna be assigned our current level sums, and then we need to also set our level. Our highest level is gonna be set to our current level. Okay, and then we return our highest level. Yeah, we return our highest level. So our current level, loop. Okay, we probably need to increase our current level here. Okay. Okay. So we have our queue, our highest level, our current level, and our biggest sum. So we loop while our queue is not empty. If the root is empty, we return early anyway, so that doesn't matter. So we have our number of nodes on a level. The current sum is always current level. So that means every time we loop through it's gonna start at 0, so we don't have no problems. So we move the first node from the queue. Then we loop and add the values, get the children, and then we get an if our current sum is greater than the biggest we've compassed so far, those become the new bigger, the sum and the level that it was on. And then we increase our current level, and then we go through it again. This should be current level. Okay. And I am forgetting to mention the time complexity and space complexity. Well, we have an error anyway, so let's see. Error: consecutive statements on the line must be separated by. I didn't comment it out. Cannot find current level node in scope. What line was that? 41. Current level node. Current level. What? Oh, I'm doing it here. I probably need to do it outside. What am I doing wrong? Over. No. Okay. It should be in this. I have it. It should be probably in here. I was about to say. Yeah. Because we want to keep it on the current level that we're on, which is here. It's in the for loop, so we want to keep it inside there. We don't want to do it outside. Because on the current level is when we also want to add the children of the level that we're on. Okay. So that's probably, this should be in the while loop. The only thing should be outside is my increase. I hate when the formatting is off. It's because it's throwing me off. I'll put expectant 1. Okay. It should be here. I think it's not increasing that. My bad. Yeah, I need it. That's the way the IDE isn't formatting it for me. I crutch, but Okay, let us submit wrong answers. So we failed some. I'm assuming it's the negative numbers that are not doing well. Can I format this? That is not what I wanted to do. Okay, let me do old school way for let. So we have our, oh my goodness, completely, what am I doing? So this should be inside of here of this. Okay, so this is for our, so this should be here. So this is closed, this is closed. This is still in our, this is not in our for loop, this is here. So let's tab this over. Like this. So okay, we need to close this and this here. So this is outside of our for loop here. Okay, so we do that check. And then we increase. Okay. Hopefully that was the issue. Okay, so now it looks better. Let us look at this again. So we have our biggest sum plus equal 1. Return our max level. Okay. I know it's the negative numbers. This is annoying. So it's probably gonna be this. This is what's throwing it off. Let's do this and see. Whew. That was amazing. Okay. That was great. Okay, so this is, so we had it at 0 at first, but we want Int.min because we want the smallest integer. So even if it's negatives, it will work in finding the maximum. Okay. That was great. Okay, let's look at some solutions for Swift. Okay, this is also using Q. It's using the root val for the maxim. So I guess I could have done that as well. So this is using a function in a function. So this is recursive. I didn't think recursion would work here, but it does look like it's working. This is using a queue. Pretty much. Is it using? Okay, it's using a helper function as well. That's a lot of code. Recursive solution, probably its own function. And a Swift solution. Pop last, but pretty much the same. Okay. That is LeetCode problem 1161, maximum level sum of a binary tree.